under numbers is continuous data. And so I was wondering, does anybody want to explain or give us a sense of what you think the difference is between discrete and continuous data? It is something which comes up in the section. And so I want to take a moment to just talk. What's the difference between discrete and continuous data? Anybody have an idea? Maybe you've heard in class. Or is there a question that your teacher asks you to ask yourself? So the way I remember it is discrete data is data that is normally counted, or it doesn't have any fractional parts. So if I had to count how many people are in the Zoom right now, that would be discrete data. It's data that's a number, and it's data that can't really have fractional parts. I count it. And so when I think about data that's discrete, I talk about, can I count it? So data that you can count is discrete data. Continuous data is data that we normally measure. So what's an example of data that we measure? Someone's height. You can be 1 meter, 81.527, you basically can go on forever, or somebody's mass, or if you're measuring somebody's time in the Olympics. This is what we call continuous data. And so mainly what you need to know is the difference between discrete and continuous data. And so I just want to check that you understand that to start with. Some examples that, I'll give you 2 examples here. Imagine you had a pair of dice and you threw them. The sum of those 2 dice would be discrete data, because you can't have 6.5 as a sum. You can only have, say, 7 or 8 and so on. So that's an example of discrete data. And then for continuous data, we also say continuous data can take on any value within a range. And so we could be talking about a person's height, because, can fall between a range or the time in a race. Cool. So let's do some quizzes on this. Let's go to answer this question for me. Which of the following is discrete data? Which of the following is discrete data? Yeah, that wasn't too bad, because you're counting, and there's 2 brothers and 1 sister. Yeah, all good. I like what I'm seeing in the chat. Clearly, you understand the difference between the 2. Okay, well, let's just quickly check then. What about this?
Sorry, Mr. Ayers, can you please unmute?
We're good. We're good. Thank you. Okay. Which of the following is continuous data? Okay, you guys, you're naturals. So clearly, this is an example of continuous data. So that's the one thing that we need to keep in mind throughout the section, whether data is continuous or discrete. That will have somewhat of a thing. The other thing that's good to get a sense of is whether the data we are dealing with is data as a list or data that's been grouped. An example of, and the first 4 lessons of this series are going to be around lists of data. But let me give you an example. Like, let's say I'm writing down the heights of people in the class. So 161, 190, 165, 168, 171, 172, 179. I've just made up let's make it 157. I've made up a list of data, which I'm kind of saying is the heights of the students in this class. Now, we can work with this data set as is, where it's a list. One of the things that I notice about this list of data, though, is it's not in an order. It's unordered at this stage. And so often when we do a calculation with lists of data, sometimes we have to organize the data from smallest to biggest. And if we had to do that, our smallest item would be 157. So just be aware it's not in order. Now, in other times when we work with data, we organize the data into groups. So I'm going to organize this data into some groups quickly. Let's say let's go like 150 to say 151 to 160, and then 161 to 170, 171 to 180, 181 to 190, excuse my funny drawing, and then 191 to, let's say, 200 or 2 meters. Okay, so what I want to know is, if we are talking about data that's in a list, it will look like the top bit. If the data is grouped, we normally have to group data into intervals. And so I just want to check if you've done some of this before. So tell me, what is, oh, the other thing is, when we group data, we have interval, and then we have a count of the amount of items in that interval. And the fancy word for that is frequency. So we talk about the frequency of that group. So how many items are there in that group? So I want to know, in the very first interval, how many items are in the interval 151 to 160? Okay, that was easy. There is just one item. It's down here. How many items are there in the next interval? So 161, what would get into that interval would be this one, this one, this one. And so it would be 3. Yeah. And how many items would be in the next interval? Well, 171, 172, 179, there'd be 3. Yeah. And what about the next one? What's left? So 181 to 190. It's just going to be 1, and which is that one. And then the last one, what we call the max value, would be in that one. Yeah. Okay. So as we come to the section on statistics, we are in the first 4 lessons, we will deal with lists of data. And in the second 4, or the lessons 5 to 8, we'll talk about grouped data. And so it's just important to make sure you have an idea of the difference between the two. So that's good. What we're going to move to now is we're going to talk about where the middle of a data set is. And so when we talk in statistics, we talk about a data set, and then we talk about where the middle of the data set is. Now, the one other thing I want to do before I move on is number of items in the data set. So whenever we have a data set, we get this thing called little n, and little n is the number of items in the data set. What are the number of items in the data set that I've just given you? So what is little n? Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9. So n is 9 for this data set. So we are going to talk about, in the next example, where is the middle of a data set. And so I'm going to move to that. But I think we've got a nice little grounding in this now.
Mr. Ace?
Yeah.
There's a question from Dawn in the chat that if the data has units like meters of voltage, for example, does it count as continuous data or not necessarily?
No, so it's not the question of continuous or is not really about units. So generally voltage would be a continuous quantity. Most scientific things, unless you're talking about people or things that you're counting, is going to be continuous. But to answer your question, no, it doesn't really. We just look at the rules that we discussed earlier. Can you count it or can you measure it? The units don't play too much of a role.
Thanks, Mr. Ace.
Pleasure. Okay, so if we talk about where the middle of a data set is, I think most of you will have seen this before, but I just want to go over it very quickly. When we talk about the middle of a data set and we want to find the mean is sometimes called just the average. And what we do is we sum up all the data. So sometimes it looks like that. And we divide by the number of items in the data set. So this is called the mean, and it's one way of finding where the middle of the data is. Another way of finding where the middle of the data is to write all the numbers from biggest to smallest, from smallest to biggest. So we talk about ranking the data or ordering the data. So that's why they say list them in order and choose the middle one. So where is the middle one? Would be the median. And then the mode is the value that occurs the most often. Okay, so let's let you loose an example and just check that I will answer if someone's unsure about how to find these things, let me know. But
Mr. Ace?
Yeah.
Sorry, Ayanda wasn't able to hear earlier. Could you please explain continuous data again?
Okay, so all I'm going to say for now is continuous data is data that we measure. So like your height or something you weigh, and discrete data is something that we count. Normally number of people, or it doesn't have any fractional parts. That is the main difference. Yeah. But you can look at the recording bit if you need a bit more detail. Okay, so let us find the three measures, A, B, and C. And what I want to point out to you is the data is not ordered here. And so if the data is not ordered, you need to do something to help you find the middle. Okay,
Mr. S, another question from the chat. Will you be doing cumulative frequency today?
No, that's lesson 6, I think it is, if you look at the planning.
Okay, thanks, Mr. S.
Cool. So I know there's 9 items in total. The question is, what is the sum of all the items, and will that help me get the answer? I see some answers coming in there. So if I add up all these items, I get 27. 2, 3, 6, 7, 8, and I got 9 items in total. And so I get a mean of 3. So A should be 3. Now, to find the median takes a little bit more thinking because we have to organize the data from smallest to biggest. And so I'm going to give you some more time while I organize my data. So 1, 1, 1, 2, 2, 3, 5, 6, 6. Okay, now, when we talked about finding the median, I think a lot of you will have listed it from smallest to biggest and found the middle item, which would be this one over here. And the reason it's the middle one is there's 4 items on this side and there's 4 items on that side. And so the median answer would be 2. However, this works really well. If you look at the median visually, it works really well if you're doing it with a small set of data. But if you've got a bigger set of data, it often works better to find the position of the median with a calculation. And so I'm going to show you a calculation for finding the median in a moment. But before I do that, let me just check what the mode is. What's the mode? It's the one that occurs the most often. And I see lots of ones. And so the answer for the mode will be 1. Okay, now, I want to ask you, have you seen the position calculation for the median, which looks like this, where you use the formula 1/2 times n plus 1 to find the position of the median? So in the chat, if you've seen that formula before and used it, give me a thumbs up. If you've never used that formula to find the position of the median, give me a thumbs down. And don't be honest, because it's helpful for me to see. Okay, so there's a mixture. Okay. What I'm going to suggest, guys, is that we learn how to calculate the position of the median early on in this process, because the same skill that we use will be able to be used again and again in other places. So hang in there for a second and just watch carefully as I show you how this works. So we all know that the median answer is 2. There's no debate about that because we can see it visually. But if the list was very long, it takes a long time to visually figure out where the median is. And so we need a more mathematical way of doing this. Now, another word for the median is called the second quartile. Now, that will only get to in the next lesson, but sometimes you will see me use the symbol Q2 for the median. And what that means is the median. Now, if I say to you, I use position Q2, what that means is I'm first going to find the position of the median, and then after finding the position of the median, I will find its actual value. Okay, so how does this formula work? So what we do to find the position of the median is we use the formula 1/2 n plus 1. Now, in this data set, what is n? Who would like to tell me what n is in this data set? Pop it in the chat. Okay, it's 9. So what I do is I put it into this formula and I go, where there once was an n, I now put a 9. And what that means, if I carry out this calculation, is 1/2 times 9 plus 1 is going to give you 5. Now, 5 is not the value of the median. We know the value of the median is 2. So why is it telling us 5? Well, this is the position of the median if we go from the beginning. So let's count. That's position 1, position 2, 3, 4, 5. And so the median will be the value of 2, but it's in position 5 in the list. Now, that's going to look a little bit weird the first time you see it, but basically, we just do a separate calculation for its position. Then once we have its position, we go to it and find it like that. Okay. Now, I want to ask a question of the class. If the position gives you a fractional number, say, for example, I say to you, the position comes out as like 5.5. Does anybody know what to do if the position has a fraction attached to it? Any ideas? What do we do if, okay, if we have a fractional number, what we do is we average it between the two closest. And you'll see an example like this, but basically you add the 2 on each side of it, and you just divide them by 2, or you take an average. But we'll see that later in the lesson. So, and I think Kevin has said you add the 2 and divide by 2. Okay, let's see this actually happening in example. But before I move on, are there any questions about finding the position? So the formula for the position of the median is 1/2 times n plus 1. Now, the good news is we use very similar formulas to find quartiles later on. Oh, my nose is getting blocked again. Sorry, guys. Sounding a bit grizzly. Okay. let's look at a bigger data set. Now, this is something called a stem and leaf plot, which I think you guys will have seen before, but I'm not sure. So I'd love some comments from the class about what does this graph even say, or what does it mean? Why do you think I would use it as a teacher? Who has some ideas about what's going on in this graph? Okay. Any ideas? What does this stem one, leaf one thing mean? Yeah. Andron, I see your hand is up. What do you think it means? You can unmute, Andron, and then I will come to you. Just unmute yourself. Can you hear me, Andron? Or Kitty Bona, I can unmute you. Can you hear me?
Yes, sir. Hi, sir.
How's it going?
Okay, so I think the stem represents like tens.
Yeah.
And then the leaf side represents the units.
Okay, you're absolutely correct. So give me the very first number in this data set.
It will be 11.
Okay, give me the second number.
12.
Okay, give me the third number.
13, 15.
Okay, perfect. Now give me the last number.
In the data set,
Yeah.
it will be 72.
Perfect. Okay. So so you're perfectly correct. The stem and leaf plot basically summarizes the data. What do you notice about it, or why do you think it might be helpful for me as a teacher to give you a stem and leaf plot, or maybe anything you notice about it?
So doesn't it give you the numbers already in smallest to biggest?
Yeah. So a lot of the time when a stem and leaf plot is given, they will have already arranged the data from smallest to biggest, which saves a lot of time. Can you think of anything else that a stem and leaf plot is good for, or just like I often include them in my exam papers?
No, sir.
Okay, so the only other reason is they take up less space. So instead of having to write like 11, 12, 13, you can just write the numbers much more quickly.
Okay, sir.
Yeah, thank you, Kidibona. That was great.
You're welcome, sir.
Okay, now the next part of this is, okay, so we've got this stem and leaf plot, and Kidibona has helped us understand what's going on. I want to ask you what is the little n for this data set, or how many items of data are in this data set? Oh, thanks, Andron. Andron was going to say stem and leaf is used to organize data. It is. Yeah, that's exactly it. It makes it sort of easier to view and to organize data. So what's the number of items in this data set? Okay, yes, it's going to be 29. So there's a lot. There's 1, 2, 3, 4, 5, 6, 7, 8, 9 in the first row. But if you add them all up, there are 29 items in the data set. Now, I want you to try and find me the median, or what we'll call Q2, or the second quartile. I want you to try and find me the median. Now, it may be helpful to use the position formula first. You don't have to, and then help find it. But basically, I'll leave it to you guys to decide what is the position of the median in this data set. The good news is the data is already organized from smallest to biggest. You get that for free. I'll give you that much. So be careful. Now, there's a difference between the position and the value of the data item. So as we go to this data set, we know there's 29 items in the data set. If you find its position, that's one thing, but then you still need to find the actual item, or the value of the item. So We go a half, and we go 29 plus 1, which is going to give us a half times 30, which is 15. Now, that is not the value. That's the position. So we count 1, 2, 3, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And so this number over here is going to be the median. And what value is it? It's going to be 27. So you can see how helpful the position formula is, because it makes it so much more decisive. And so we should be getting an answer of 27. Does this method work well with raw data? Bongeka, it only works if your data is arranged from smallest to biggest. So if you count to the 15th position and your data is not in order, you won't get the median. Okay. But this formula works really well for quartiles and percentiles and all sorts of stuff. Okay, bonus question. What is the mode for this data set? What is the mode for this data set? Remember, what is the mode? The mode is the value that occurs the most often.
Mr. S, are you still there? Okay, guys, Mr. S is experiencing some technical difficulties, but please hang in there. He will be back soon. Mr.
So
S, can you please unmute? Oh, there we go.
So I think you all got mode 17. And I tell you what, guys, let's take a bit of a break. We've been working hard, and I think we need to stretch it out. So on your feet, let's stretch it out. And my recommended exercise for the day is right hand, left quad. See if you can do it. And then switch. I was in a class with grade 3s today, and we were doing this to get them warmed up, and they were going for it.
That's awesome.
I don't think you'll beat their enthusiasm, but it can just bring you as much energy, I'm sure, as well. And then just do whatever your favorite stretch exercise is. Just give your body a break, loosen up your shoulders. Yeah, and just take a moment to let your brain wander. Because, yeah, you've been working your brain hard, and you need to give it, some TLC. Okay, cool. Has everybody stretched it out? I want to see those happy faces that I know are going to happen when you stretch. All right. If you've stretched, give me a happy face in the chat. Okay. There we go. Shane has stretched, Mclody, Mbo. You see, you know why they're smiling? Because they stretched, guys. So you need to stretch too. Invest in yourself. Okay. While we wait for the rest of our students to stretch, give this little brain break a go. And it's not using normal maths, but it's using a pattern. So see if you can figure out how this puzzle works, and you have to try and figure out what the value of this is. Okay. So keep, and you can give some ideas in the chat if you like, as to how to do this. I don't know if I get 77. I know using normal maths, it would be 77. I agree, like 50 plus 20. But if you look at the pattern here, 21 plus 32 doesn't give you 35 normally. 33 plus 42 doesn't give you that. So there might be something else going on here. Abnejo and Kidibona, what do you want to give us some hints? Ayanda, what will you guys give us some hints there? What were you guys doing? What pattern have you spotted? I'll give you guys a hint. Imagine 2 plus 1 gives you 3, and 3 plus 2 gives you 5. And then if we go here, 3 plus 3 gives you 6. 4 plus 2 gives you 6. So what do you think the final answer is going to be here? I think a lot more of you are getting it. So using this rather funny algebra, I know. So this is not normal maths, right? This is just a pattern. And so using the pattern in this particular setup, 5 plus 1 would be 6. 2 plus 6 would be 8. You get 68. However, if you do that in normal maths, you offside, yellow card. But for this particular section, for the pattern today, it's 68. Yes. Cool. So I thought that was something a little bit different that I like the look of. So I hope you enjoyed that. And so now we are going to return after our little thing to our data. Okay. Oh, Ayanda used a different method to get there. Interesting. Huh. Maybe there was another way of doing it, because I just looked at, oh, sorry, I went to the wrong thing. You obviously went a different way of getting to the answer, but you would have got the same answer in the end. Okay. Cool. Let's go to the next question. Let's do this. So I want you to start by finding me the mean for this data set. Find me the mean for this data set. I'm glad you liked it, Pussy Siwe. So find me the mean. This is a data set with the temperatures in London on the Fahrenheit scale throughout the year. And so when we try to find the mean of the data set, we always know that we're going to need to find the number of items, or n, and then we're going to have to also sum up all the data points in the data list or data collection. So Andron will do a little bit of standard deviation maybe in the next lesson. We'll see how the lesson goes, or lesson 3. I don't know if we'll do the variance in detail, but we'll definitely do standard deviation. Okay, so what did we do? We know that n was 12. And if we add up all these data items, 38 plus 39 plus 6, 58 plus 62 plus 62 plus 51 plus 594, and 594 divided by 12 is 49.5 Fahrenheit, so 49.5. Okay, that is the mean. You're quite right. What I want you to now find me is find me the median. Find me the median for this data set. And if you want to give us some hints or tips, I would love that. So to find the median here, you have to recognize a couple of things. And so if anybody wants to give us some free tips for step 1, please raise your hand or put it in the chat. Now I will share. Okay, Bongeka and Sarah, put the numbers in order. Yes. So step one, to find median, these items are not in order. And so let's start by putting them in order. So 40, yes, 42. That's my tip to get you going. From the class. Okay, so that's the data arranged from smallest to biggest. What is the next step? And I think the next step would be, if we were using the position method, would be to ask ourselves, what is the position of the median, or what I'm calling position of Q2? And the formula we used before was a half n plus 1. So think about it for a moment. If the position of the median or the position of Q2 is the formula half n plus 1, then when we use n is 12, and now we have a problem, well, not a big problem, but the position of the median is 6.5. And so what does that mean if the position of the median is 6.5? Would anybody like to just explain what we do? I mean, Kevin, you knew earlier in the lesson, if the position of the median is position 6.5, how do I calculate what that median is? Okay, let's go to Isake. What do we do in this type of scenario, Isake? I'll unmute you now. If you just click the little bubble and you can unmute. Yeah.
I think we have to add two missing numbers and divide by 2.
Isake, that's exactly it. So we find the two numbers, the number in position 6 and the number in position 7, because those are the two numbers that are going to be on each side of 6 and 7. Thank you, Isake. That was wonderful. So we go 1, 2, 3, 4, 5, 6. So the 6th and 7th numbers are here. And so because our position of the median falls between those two, so basically it's falling here. Okay, what we need to do is we need to add the two numbers together. So 46 and 51 and divide by 2. And what answer is that going to be? Which of the 4 options? It's going to be option A. So it'll be 48.5. That one there. So the good news is the position formula doesn't get frightened of fractions. All it means is that we take the average between the two numbers that are closest if we're finding the median. Okay, one more question. What is the mode? What is the mode for this data set? What is the mode for this data set? Okay, that was quite easy. The mode is going to be 62 because it occurs twice. So you guys got the mode very quickly, but now I want to ask you another question. So we found the 3 measures of central tendency, the mean, the median, and the mode. It feels like 2 of the measures do a good job, but one of the measures doesn't do a very good job. So remember that the job of these statistics is to find the middle of the data. Which of the 3 do you think doesn't do a very good job of showing the middle? Does anybody have an idea of what I'm talking about? Like, as I look at the answers, the very first answer, the mean was 49.5. The median was 48.5. And then the mode was this one. So the question is asking you, you found the middle of the data in 3 different ways. I want to know, do you feel like one of the measures doesn't do a very good job of finding the middle? I'm just asking. So basically what I'm leading you to is The mode, yes. Can you see how the mode says it's the middle, and yet it's the biggest number in the group? So if you look at it, the mode is 62, and yet that doesn't feel very much like the middle to me. And so one of the things I want to just point out is, though, even though you can almost always find the middle of the data with these three ways, sometimes some of the measures will be more appropriate than others. And we'll talk about that more going forward. But I just wanted to point out that the mode doesn't feel like it really, yeah. So Ayanda, what we were learning is we were just learning about the three different ways of finding the middle of the data. And while we did that, I taught you a technique for finding the median that I think will be useful going forward. Okay. If you want to find the range, Maklodi, the range is not a measure of where the middle is. The range is a measure of how spread out the data is. And so the next lesson is going to be about something called measures of dispersion, or how spread out. But just to answer your question, the range is just the biggest minus the smallest. So in this data set, the biggest is 62, the smallest is 38. And so you would just subtract those two. So Loretta, the mode is the one with the highest frequency. Yes, it's the one that occurs the most often. But sometimes that isn't always the best measure of where the middle is. Okay. Let's go on to another question here. Find me the median for this data set. So we've got A, B, C, D. Find me the median for this data set. So ask yourself, what is the first thing you do when you're finding the median? And earlier on in the lesson, I remember somebody said you always organize it from smallest to biggest. And so if it's already organized for you, you just say, thank you, teacher, moving on. But if it's not ordered, you need to order it first. And so from smallest to biggest, so 48, 52, 58, 60, 60, 67. Okay, so now using the method I was showing you, the position of the median, or the position of Q2, is going to be a half times n plus 1. In this data set, there are 6 items. If I count them, 1, 2, 3, 4, 5, 6. So a half times 6 plus 1, and that is going to be position 3.5. So if it's in position 3.5, what value is it going to have? So let's count. 1, 2, 3. So it's going to be here, which means I'm going to have to average out those two. And so the value of my median is going to be 59, which is C. So take a moment to understand that. I want to ask for questions from the class if that's not clear to you. We first wrote the data from smallest to biggest because we were finding the median. And then we used the position formula to find the position. The position was a fraction. And so it's between positions 3 and 4. And so what we did was we added position 3 and 4 together, the value, and we divided by 2, and we got 59. Are there any questions about that? Okay, let's do, I think you all can do the mean. Let's go to this, not that one. Let's go to this data set here. Okay. If we look at, in fact, let's not do that data set. Let's do this data set here. That's quite a bit bigger. find me the median for this data set above. Find me the median for this data set over here. Or let me put the official symbol of the median, Q2. So find me the median of this. Now, is it ordered from smallest to biggest? Oh, thank you, teacher, for being a good teacher. You put it in order smallest to biggest. Now I want to find the position of the median. Position, I'm going to use this formula. And how many items are there? There's 7, so a half. So that's going to be 4. So the median is in position 4. 1, 2, 3, 4. So the median is going to be 20. Yeah. So it's in position 4 in this list, and the value of the median is the value 20. So a really important idea I want you to start to get used to is the difference between the position in a list and the actual value itself. So this is the middle of the data, and you can see that it's dividing it fairly evenly. Okay. Now, I want you to find me the mean. Find me the mean of the data set over here. So we need to know how many items are involved. So 1, 2, 3. We know that there's 7, and then we might need to do some adding. So be careful here. We're looking now not for the median anymore. Remember, we're looking for the mean, which is the average of the data set, or the mean is a different type of measure of where the middle of the data is. So we should get 20.14. So guys, I've spent a lot of time today on the median, and I don't want you to forget about the mean. The mean, you just add up all the data items and you divide by the number of items. Now, what's interesting is, can you see that the median and the mean aren't too far apart, which is interesting. You know, the median was 20, the mean was 20.14. What is the mode? What's the mode for this data set? Okay, I'm being a little bit sneaky. Yeah, there is no mode. Or, yeah, not applicable or no mode. Yeah, exactly. Okay, so I want to finish today with a little preview of the next lesson. So you've done really well. The whole point of today was just to talk about different types of data and then finding the middle of the data. And in the actual lesson, I spent quite a bit of time on teaching you the position formula. And I want to end the lesson with a little bit of a preview of something called quartiles. So what you have here is a much bigger data set. And sometimes when we talk about bigger data sets, we don't just talk about the middle of the data, or what we call Q2. We often are interested in something called Q1, which is almost like the middle of the lower part of the data. And we talk about something called Q3. And what Q1 and Q3 do is they divide up the lower half and the upper half of the data. One way of saying it is 25% of the data is down here, and 25% of the data is above here. What these measures do is they're basically telling you different positions in the data set. Now, most of us are most familiar with quartile 2 because that is the median. It cuts the data into 2 halves. However, we also need to know how to find basically where the first quarter of the data stops, which is Q1, And we also need to know where Q3 is, which is basically 3/4 of the way through the data. Now, the good news, guys, is that we use very similar formulas. So if you want to find Q1 is, you use a formula to find the position of Q1. And the formula you use is 1/4 times n plus 1. If you want to find the position of Q2, which we've done throughout, we just use that formula to find its position. And the position of Q3 is just going to be 3/4 times n plus 1. Now, this is just the position. It's not the value. The value is going to be the value of that number in the position. So what I want to do today to end off with is I want us to try and find the value of Q1 using this idea. And I'll tell you how many items there are on the data. 1, 2, 3, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. Okay. N is equal to 22. There are 22 items in the data set. I want you to try and find me the value of Q1, which is, we call that the first quartile. It's 25% of the way through the data. See what you guys get. We're just going to find Q1 for now. Okay. So we know it's in position 5.75. Now, because that's not an exact position, we need to average it out between the two closest numbers. So I'm going to count 1, 2, 3, 4, 5, 6. We know that Q1 is going to be between basically 12 and 15. And so we go 12 plus 15 divided by 2, and that would be 13.5. Buchle, you're quite right. There is no 5 in the data, but this is finding me the position. This is a position which is between numbers 5 and 6. But in order to find the first quartile, you should get 13.5. Now, we are going to spend the whole of the next lesson on this. So I was just squeezing in a bonus round here. But what I wanted to show you is that in statistics, it's quite important that, especially that we order the data. So especially when we talk about quartiles and medians, we order the data. Then we think about what is its position, and we actually do some specific calculating. And then after we find the position, we can go and find the value. So Dawn's question is, isn't there a specific rule if it ends with a 0.75 or a 0.3? Okay, Dawn, the way it works is for quartiles, and we average it out. So basically, for whenever you're finding the quartiles and the medians, you just average it out between the two closest numbers. When we are dealing with something called percentiles, you round it off to the closest one. Okay, so I'm going to point that out for now. So Dawn is asking, like, for example, if you had got 13.3, or shouldn't you go, or sorry, if you got 5.75, shouldn't you go to the closer one, which is 15? And the answer is no. For the quartiles, you average it out. Yeah, so Kevin, even if it's 5.99, you would just average it out. But once we get to percentiles, we go to the closest one. Okay, and that's just almost an artificial rule from school. So I know what you're saying. It is a little bit artificial, but that's generally how most exam papers will be marked, that they'll follow that standard. And so you just average it out for the quartiles. Okay. But we will continue with this in the next lesson. That was bonus for today. And I think you've done very, very well. And so I don't want to go any further. I don't want to get into the next lesson content. So guys, what we're going to do is we're going to finish with a poll. And so this just helps us know if we're meeting the pacing needs of most students. And so please, could you help us by filling out that poll? And then while you do that, if there are any final questions, now is the time. Otherwise, we'll start to wrap this lesson up. Okay. So again, be honest in your assessment there, because we try and do the best job we can, but we also need to get accurate information from you guys. Are there any final questions? So what if I round off to a whole number? Will I get the same number? So Mokhlodi, what you do is, well, in the next lesson, I'm going to go over this again. So I think for now, I'm going to press pause. In the next lesson, we will clarify this in absolute detail.